Hi all. So today we'll see on all the until now we saw how a transformer works and few of the concepts related to transformer, right? So today we'll take a step back, right? I would say multiple steps back and see what I just realized this, right? So we speak a lot about transformers, LLMs these days, but what made LLM a big deal, right? What learning task is being employed on LLM? Okay, so let's see that. Okay, so the idea behind a large language model training or learning task is nothing but self-supervised learning, right? So in let's focus on supervised learning for now. Okay, so in supervised learning there are two ways, right? Basically there are two ways to learn from the data, right? One is using classification and the other one is using regression, right? So in classification you have the target be a category, it could be a 0 1 or it could be some kind of classes or categories, right? And regression, the target variable is nothing but a continuous value. Okay, I think we all know we have we learned much about all this, right? But in classification there are multiple subcategories of classification, right? So we call it binary, multi-class and multi-level. So of all three, you know which category the LLM falls under?
Mm, I have heard LLMs are into transformers technology, generative AI, right? But as you mentioned, it's very rare we compare towards regression and classification. In my guess and also the observation, I feel it's more into classification, classifying into the vocabulary, or in terms of image or video, I'm not sure how it's happening. So,
Okay,
yeah.
so let's focus on text, right? um, let me draw something, uh, basically a transformer here. So we all know like transformer drives LLM. So I'm going to draw transformer architecture, just a basic encoder decoder architecture, right? So in this, let's say a decoder is the final, I would say a part of the transformer which does the prediction part, right? So basically you have a list of vocabulary, right, which the transformer or the model needs to predict what will be the next word in case of LLMs, right? So a vocabulary is nothing but the list of in learning a supervised learning task, you could translate this as multi-class use case, right? So where all the tokens in the vocabulary is nothing but the different classes which are independent to each other. Okay, so a simple iris data set, right, wherein you need to predict what class a flower falls in, that could be related to a LLM training as well. Isn't it cool?
Yeah, exactly. So if we connect the dots, every word is a multi-class classification, right? Each and every word it's generating
Yeah.
itself is a multi-class
Yeah.
classification task.
And if you perform greedy decoding, what, let's say our task, LLM's task is to predict the next word, right? So out of, let's say it has a vocabulary of around 10,000 tokens or words, whatever, and out of the 10,000, if we perform a greedy decoding, whatever token has the maximum probability gets used as the next token. Okay.
Yeah, that's right.
So this is how you can relate multi-class with LLM. I thought this could be, I mean, some might feel this is usual, but maybe most might think uh, as a new thing, right? So that's why I thought of sharing it
Exactly.
today.
Yeah, if we are dealing with the regression classification, this might be evident. But Praveen, could you also show with the live example? Could we relate with the ChatGPT generation?
Yeah, of course. So ChatGPT is nothing but a decoder only transformer, right? So let's focus on this part alone. Now you'll be supplying text, right? Also the text will be converted into embeddings and you add position embedding to it, and then it goes through self attention layers, right? So I think we all know the story, but in the end the goal here is you get a input token, right? Let it be a start token or the context or the prompt from the user, right? So this is a list of tokens, right? So this will be the input to the decoder, and with this it tries to predict the next word. Okay, doesn't matter what the prompt is. It goals is the goal of the transformer is instructed. It is instructed to predict the next word, and it should be friendly with the human. Okay.
All right. Okay, let me try something in a chat GPT. Now let's see, or could you relate how the multi-class classification is happening? So I understood every word is like a multi-class classification, right? I'm trying to relate it with the chat GPT example. We see it's a generative form. So every word is getting generated. So let me try a prompt here. Let's see if it's much relatable. Yeah, could you explain with this example?
Okay, sure. So in this context, the right you just prompted ChatGPT saying write a poem on A, right?
Yeah.
So this is a set of tokens. This will be an input to the decoder of the transformer, right? So with this list of tokens as input, it tries to predict the next word or next token from A, right? So A is the last seen token, uh, or the last seen information for the transformer, for the decoder.
Yeah.
Now using all the context, right, starting from right till A, it uses this information and tries to predict the next word, right? But you should also think about, like, it has been trained on millions or tons and tons of data, right? So it already has enough information. You are just triggering, or you're just focusing the decoder to uh, basically to focus on a set of area in order to generate the content.
Right.
So, and it generates token by token, right? So meaning, so once it generates in this context, right? So it uses the input starting from write a short poem on AI, and in will also be added to the context here. So using all the using this additional token, it tries to predict the next word, real realms, right?
Yeah.
So this is how the prediction is being made. And whenever it tries to predict, let's say in this case, I think they are employing sample decoder technique here, right? So we spoke about greedy decoding. So this is some a little bit different from a greedy decoding, but you can think of this like the tokens, which is the best token among the list of tokens, right? So it chooses based on that. And so in this context, in out of all the vocabulary of all the tokens in the vocabulary, in is the best token, so it has selected that. And then using write a short poem on AI and in, it tries to predict the next word, realm, right? So this is how the predictions are being made, and the way it predicts is an hyperparameter in itself. So it could be greedy decoding or beam search decoding, whatever. It depends on the use case.
Got it. So tell me if I got it right. So maybe if in the first time, out of all the vocabulary words it has, the first time it is predicting in. So this has the highest classification score. And the second time, realms. The third time, off. The fourth time, maybe code has got the highest classification
So
score, right?
we are
Awesome.
I believe we are little bit out of the topic here, but it's all fine. I think you got the gist of what we are speaking. But now we are entering into the scope of the different types of decoding techniques.
Right.
We'll figure out how this thing happens in the next video. Okay, but as far as I can understand, like, this is how the decoding works. Let's focus on the multi-class part only here, right?
Right.
So out of the list of tokens you have, only a handful of tokens get selected. That's the goal of this video.
That's right.
Yeah.
Thank you so much for that neat explanation. Let's figure out the multi-class decoding in the next video.
Yeah, and we'll also see what are the different types of decoding techniques, right? It could be greedy, beam search, or sample decoder. We'll see why, on what use cases you need to use all these different types of decoding. Thank you.
Sure. Thank you.